Welcome to this series on internal assessment. What I'm doing here is I'm trying to answer all these questions. If you go to the forum, you're going to see that there's heaps and heaps of questions. So if you go to IB Survival and you go down and look at what are the questions all about here. IA guide, failed results from my IA, Chemistry IA, what defines an IA. You can see that by far the biggest questions that students have are to do with internal assessment, and even if you go to the special website that only IB teachers have access to, you get the same thing. Even the teachers are asking IA. So what I've decided to do is show what I do for IAs. I'm just going to go to my Google Classroom and I'm going to just pull up the IAs from my students and just show you where I'm at. Now these resources here I'll make available on my website. I'll just put them there. I'll put the links to that in the description. And this template especially, IB doesn't like templates or checklists, but I have had this checked by a very experienced IB internal assessment examiner. We've gone through this, and these are really the main things that you need to get, and I'll be working my way back to this quite often. So I'm going to put some anonymous reports out there. I'm hoping that all of you will watch it, and I'm talking to my students here. I'm putting them up anonymously. You're going to have to go and look at each other's and get good pointers from each other like I normally do in class. This one is on the pH changes and how that affects the CO2 that's produced, and they've tried to do this for cooking. And so if we look at this here, it's a bit of an introduction, good referencing. There's chemical reaction in there. This is chemistry. If you don't have a chemical reaction in your introduction, that would be interesting. Alright, that's usually just the start with chemistry, and it's one reason why I don't really ask for this until we've finished topic 10, because topic 10 is really good at showing you where the electrons go and so forth, and the redox as well, topic 9, so we can get into worry about that later. Got some reactions here. I don't know why that's in bold. That's not following conventions. Alright, we're worried about the data, so let's not worry about these little tiny things. But I'm just going through this. Looks to be a lot of effort in here. Just polishing. Oh, look at that. Alright, that's nice. Are they your only controlled variables? Alright, another major concern is temperature. We don't really care. Like, the temperature of the room is important. Alright, that's probably going to be what your starting temperatures are, but the thermometer must be inside the reaction vessel, and that's the temperature that we're after. And so you need a lot more controlled variables. And this one's quite relevant because we're dealing with gases as well. And so sometimes it's not that relevant. Oh, here we go. Okay, still could have more details. Everyone does this. Don't know why. I do it too. Maybe it's my fault. Alright, I keep on saying mils because I'm lazy. Mils, centimeters cubed. That's 5 syllables. Alright, so method. I'm getting picky on this student because this is me when I'm happy. Look at that. Oh, you can just look at. I don't even just skim it. I can tell it's okay. Of course, it's never perfect. So we'll get to that in a second. Diagrams. You're always meant to have a diagram. Picture says 10,000 words. I think it's the proper way. It's not 1,000. It's 10,000. I want photos. I really want photos. Photos show me all the truth. All right. Of what really went on, and I can analyze the detail of those photos and see what's wrong with the method as well. So I want labeled photos, not just one, maybe more than one, depending on what's relevant. Okay, looking at this table here, 1, 2, 3, 4, 5, range of 5, repetition of 3, brilliant. What do we have here? Don't try gravimetric analysis unless you got something that's this good, a Metler balance. Haha, you've fallen for this. This is a digital. Go check your analysis on that. It doesn't even make sense anyway. Look at this. It's going up in 0.01s. Maybe that's the uncertainty. I'm not saying it is. Go check the PowerPoint. Topic 11 PowerPoint. So it goes up plus or minus 0.05s, but their data disagrees with that. So that's probably the biggest problem that students have with uncertainties. They don't actually understand what they are. All right, that's how your uncertainties is how you're measuring. All right, it's how accurate your instrument is, and so you should be measuring to half the smallest increment. But this is a digital instrument; it's different, so you can check that yourself. But you can tell here that it's different, so there's something wrong. So this is a brilliant table. Well, I just look at it and I can see all the answers. All right, I don't want to see 6 tables. All right, get creative. Think about it, make it clear. Alright, so I can see everything in the one table. Alright, I prefer one table. Alright, this is what I prefer. Okay, so there's plenty of IB exemplars that get really high marks and they've got messy, ugly tables all over the place. Hard to understand. Whatever. Alright, don't want it. So, brilliant table. As always, never perfect. Got something to fix up. Okay, and graph. It's a bit fuzzy. Alright, so when you do cut and paste, what you do is you blow it up to the entire screen, and then you cut the whole thing out, and then you stick it into your document and you shrink it down, and that gives you the really high pixelated quality things. Now this is brilliant. Let's go over the brilliant stuff first. Alright, you haven't put error bars here. If they're too small to be seen, write that down here, too small to be seen. Do a better job than that. So you've got uncertainties, you've got a line of best fit, brilliant. You've got error bars, uncertainties here, but you don't have that doesn't correlate well in this graph, so you need to do the 0.0s, and same here, 5.00. Now Excel does this. It's the only program that does, believe it or not. Had decades of computers and they still can't get their programs very good. You deal with that. If you don't have the program for that, we'll get a text box and paste it on top. We'll get a pen and write it in there. Alright, just do it. It's got to be perfect. Average mass of CO2 produced. Put a little 2 down, please. So you've got that there. So there's a couple of small things to fix here. What is that? Y equals what? You've had to draw that in freehand. Look, it doesn't match. Look, that's not the tangent. I can see a bit here. It's probably up here somewhere. Alright. You know, the physicists might be useful here. They do 2 lines of possible best fit, and that's how they get their uncertainty, but that's way beyond chem. So just stick with that. Get a decent tangent and get your uncertainties by x on y, which is, you know, this uncertainty and this uncertainty. So that's how you're going to get your rate uncertainty. So you've done really well there. There's only just little fixes on that. Shout out to Richard Thornley. There you go. This is one of my better students. This is a standard level student too. So I think he said in one of his videos he'll eat the graph if he sees a perfect graph, and he's only ever seen 3, and he's had to take the piece of paper and eat it. On first attempt. Alright. I don't have as much experience probably, and I've never seen a perfect graph first off. So same deal. Alright. So that was an example of how it's done, and then you do it for all the different pHs, and then you get what you really want. That's pH 4, pH 5, pH 6. Where's the graph? What we really want, which is, you've given me an example one there which we've analysed. I want now this one versus this one. The reason it's not done is because you haven't done the value, so you can't do it. Alright, but you're on the right track, you're almost there. You haven't done the rate, so you need to do the delta y and delta x with the uncertainty propagation. Then you can do the real graph. So there should be 2 graphs for this one. An example of how you got the rates, which is pretty good, and then the actual one that we care about, which is the pH versus rate. Now I've got a video I think on how to do that. If I do, it'll pop up in the corner. If I don't, well, I don't. It's in the videos as well, and I've explained it here, so it should be fine, I hope. What are we doing? So very well done. actually the only thing I really care about is that you've got your data, and you do. A little bit concerned that you haven't controlled the temperature. That's where the photo will come in. How good are you at I hope I don't see a Photoshop. I'll be blowing that up and look for pixelation on that. Is there a thermometer inside your beaker? I'm pretty sure I told you all to do that, so I hope you do have a photo of that to prove it to me. And you need to put that in several places. So your data's pretty good. Everything's pretty good. Okay, so start working on your rate, your uncertainty, do your graph, and continue on. And maybe hold off on that until after Christmas, alright, when we've got a bit more time for that. We've done our mocks. Okay. If you found that helpful, please like it and put some comments in the comments below, and please check out the other videos for more advice.